So far we have seen the basic concepts of hypothesis testing. Now the question that comes to the mind, we are performing a hypothesis test. Is it possible that we commit some sort of an error? And the answer is yes. In hypothesis testing, we can have two types of error. One is called the type 1 error and the other one is called the type 2 error. In order to understand what is the difference between the type 1 and the type 2 error, let's see this particular diagram. Look at that. What I have done here, I have a table, right? And on this side we have the null hypothesis, the status about the null hypothesis, and on this side I have whether we are rejecting or we are not rejecting the null hypothesis. So it all starts with the null hypothesis, right? So what happened? Let us suppose we have a null hypothesis which is true and we fail to reject the null hypothesis. So it means we have a correct decision, right? We have a correct decision. Why? Because we fail to reject a null hypothesis which is actually true. We shouldn't reject something which is true. Let us suppose we have a null hypothesis which is true and we reject that. So in such a situation, in such a case, we have committed a type 1 error. So what is a type 1 error? A type 1 error occurs when you reject the null hypothesis which is actually true. So null hypothesis is true and you are rejecting it. So it means you are committing a type 1 error. Now let's look at the other scenario. The null hypothesis is false and we fail to reject the null hypothesis. Right? Something which was false, we would have rejected that, right? But we failed to reject that. So such type of error is called the type 2 error. So what is the type 2 error? A type 2 error occurs when you have a false null hypothesis which you fail to reject. And if we have a false null hypothesis which is not true, which is false, and we reject the null hypothesis, it means we have made a correct decision. So with this chart, you can very easily understand when a type 1 error occurs and when a type 2 error occurs. So let's understand that. Type 1 error occurs when we reject the null hypothesis when it is in fact true. The probability of making a type 1 error is called a significance level and it is denoted by alpha of the hypothesis test, right? It's a significance level, alpha of the hypothesis test. So the probability of making a type 1 error is denoted by alpha, and this is also called the significance level of the test. And what is the type 2 error? Fail to reject or not rejecting the null hypothesis which is in fact false. So you fail to reject something which is false, so you have committed an error, and this is called a type 2 error, right? And the probability of making a type 2 error is denoted by a Greek letter beta, right? So this is the letter we're talking about, the beta. The probability of making a type 2 error. The probability of making a type 1 error is denoted by alpha, and the probability of making a type 2 error is denoted by a Greek letter called beta. Now let's see an example. What we have an example here. We have the null hypothesis. Look at the null hypothesis. The defendant is innocent. And we have an alternative hypothesis. The defendant is guilty. We are asked to describe the type 1 and the type 2 error. This is what we are going to do. So we are given a situation. This is a court-like situation. This situation occurs in a court of justice, right? So when you go in the court, you are considered not guilty or innocent unless proven guilty. This is very famous saying in a court, right? You are not guilty, you are innocent unless proven guilty. So let's say we have the null hypothesis that the defendant is innocent, and we have the alternative hypothesis the defendant is guilty. You have to describe the type 1 and type 2 error. Now what will be the type 1 error? Type 1 error will occur when you reject the null hypothesis which is actually true. The defendant was innocent but you fail to reject that, you have committed a type 1 error. It means you are punishing an innocent person. So you are committing a type 1 error. You are actually punishing an innocent person. And when the type 2 error will occur, type 2 error will occur when we fail to reject the false null hypothesis, which means the defendant was actually guilty, but we fail to reject that, right? We actually let go an innocent person unpunished. That is going to be the type 2 error. So in this example, I try to explain you that in this situation, how you can have a type 1 error and how you can have type 2 error. So look at that once again. Type 1 error, when you punish an innocent person, you have committed a type 1 error. And a type 2 error, when you let go a guilty person unpunished, you have committed a type 2 error in this particular situation. Okay. So what are the possible conclusions? So we are performing a hypothesis test. So now we want to see what are conclusion. Actually, when you are performing a test, it has to have a conclusion. Otherwise, there is no purpose. There is no purpose of performing the test. So what are the possible conclusions? Suppose that a hypothesis test is conducted at a small significance level. If the null hypothesis is rejected, we are rejecting the null hypothesis, we conclude that the sample data provide a sufficient to support alternative hypothesis. If you are rejecting the null hypothesis, it means our sample data suggests we have enough evidence to support alternative hypothesis. And if we fail to reject the null hypothesis, we conclude that the sample data do not provide a sufficient evidence to support the alternative hypothesis. Right? This can be understood by a diagram. Let me make a diagram so that you can understand very easily. Let's see a diagram. Now look at this simple infographic. Look at that. This is the null hypothesis. We want to see what is the null hypothesis. Is the null hypothesis needs to be rejected, or the null hypothesis we are in a position to fail to reject the null hypothesis? If one of the two will happen. If we reject the null hypothesis, then what happens? We actually support the alternative hypothesis. Our data, our sample data provide enough evidence to support alternative hypothesis, right? And if we fail to reject the null hypothesis, it means we fail to support the alternative hypothesis, right? So with this infographic, one can very easily understand what is the decision, how we are going to decide our hypothesis test. So remember again, if we reject the null hypothesis, we support alternative hypothesis. If we fail to reject the null hypothesis, then we fail to support the alternative hypothesis. Now you might be wondering how we decide that we have to reject the null hypothesis or we are in a position to fail to reject the null hypothesis. Who will decide that? And this is where the test statistics comes into play. So what is the role and what is the purpose of the test statistic? The test statistic is the value used in making a decision about the null hypothesis and is found by converting the sample statistics to a z-score with the assumption that the null hypothesis is true, right? And the good thing is that we have a formula for that. And what is the formula for that? It's equal for the one population mean. When the sigma is known, we use this formula. We have already seen this particular formula, right? When we were doing the sampling distribution, we converted the z-score. This was used to converting the z-score. This is the sample mean minus the population mean divided by the standard deviation of the population over the square root of the sample size. That's how you convert. That's how you convert or you find a z-test statistic, right? And this z-test statistic will decide whether we have to reject or we are in a position to fail to reject the null hypothesis. How we are going to do that, I will show you. So up to this point, we have two approaches of hypothesis testing. One is called the p-value method or a p-value approach, and the other one is called the critical value method or a traditional approach, right? So far, what we have done so far, both up to this point, both method works the same way. Up to this particular point, up to this test statistic, both approaches for hypothesis testing work exactly the same way. Let me repeat what you do. You first of all, you write the null hypothesis, you write the alternative hypothesis, you decide the confidence level, and you decide the type of test. And then what you do, you then find the test statistics. So up to this point, we have the same thing. But from here on, the two approaches come into existence. One is called a p-value method, and the other one called the critical value method. We will discuss these approaches one by one, but in this video series, first I will discuss the p-value method. Once we are done with the p-value, then we shift our attention towards the critical value method. Why I'm using the p-value method? Because p-value method is most prevalent in the statistic literature, right? Most of the people use this p-value method, right? But both method will give you the same answer. Both method will result in the same thing, but the p-value method is more prevalent. So let's see what we require. So in order to understand the p-value method, you need to understand what is a p-value. What is a p-value? Let's understand what is a p-value. A p-value, or the probability value, is the probability of getting a sample more extreme than the one observed in your data, assuming that the null hypothesis is true. It is basically the area outside the test statistic. Let's see that. So it all depends upon what type of test we are using. If it's a left tail test, the p-value is the area to the left of the test statistic. If it's a right tail test, the p-value is the area to the right of the test statistic. And if it's a two-tail test, the p-value is twice the area in the tail beyond the test statistic. Right? This will become more clear when I show you infographic on the next slide. This will become very clear to you guys. Right? Let's see what is the infographic. So I ask you guys to pause this video and look this infographics very closely, and you will understand what's going on. Once you are done with looking at this one closely, I will explain it. So look at that. First of all, we need to decide what type of test we are doing. What type of hypothesis test it is. I told you in the earlier video that hypothesis tests are of three types: left tail test, a right tail test, or a two tail test. Let us suppose the first that it is the left tail test. If we are performing a left tail test, for hypothesis test, then the p-value is the area to the left of the test statistic. Look at this, is the test statistic, and this entire area, which is shown in the purple, whatever the color that is, that is the value. That area is the value. That's the p-value. That area is the p-value. Let us suppose that it's a right tail test. Right? If it's a right tail test, what happens? Then the p-value is the area to the right of the test statistic. This is the test statistic, and this area will be the p-value. And what happens if it's a two-tail test? Then we have a two situation. If the test statistic is to the left of the center, if the value of the test statistic is to the left of the center, then the p-value is twice this area. You find this area and you double this area. And if it's a two-tail test, but the test statistic is to the right of the center, look at that, this is the center, and this test statistic is on the right side, then what you do, you find the area to the right of this one and you double it. P-value is twice this area. So by using this infographic, I am hoping you are able to understand that how you compute the p-value in a different situation, when it's left tail test or right tail test or a two tail test. In the next video, we're going to see more examples and how to compute these p-values. We will do some practice. I hope you understand this video. Thanks for watching. In the previous video, we have seen the concept of a p-value and what is a p-value and how the p-value look like in a case of a left tail test, in case of a right tail test, and in case of a two tail test. But we were not able to do any practice at that time. So now, for the practice purpose, let's see some examples. This is example number 1. You are asked to find a p-value given the following information. It's a left tail test, with z equal to 1.71 as a test statistic, right? So what we are going to do now, we are going to draw a normal curve, a bell-shaped curve here, right? Let's draw that. This is a bell-shaped curve. Exactly in the middle, we have the mean value, which is 0. We have 1, 2, and somewhere here a 3, minus 1, minus 2, and a minus 3, right? So let's look at this value, z equal to 1.71. 1.71 will be here, right? This 1.71 will be somewhere here. So you have located this value 1.71, and as it's a left tail test, so the area, this area on the left, this is z equal to 1.71. This entire area will be the p-value, the area on the left of the test statistic. Why on the left of the test statistic? Because it's a left tail test. This is going to be our p-value. This is very important that you understand that. Now this p-value can be found by using a table. You can use a table or you can use Excel. It's up to you now, right? So let's first see how I'm going to find this via table. So let's go to the normal table and let's see what we have. So our z value is 1.71. So what I'm going to do, I'm going to look 1.7 in the extreme left column and 0.01 on the top row. So 1.7 is here. This one 1.7 and 0.01 is here. So the answer comes out to be 0.9564. 0.9564. So that's how you find the area. So the p-value is 0.9564. That's what we have done by a table. Let me do it via Microsoft Excel. Let's see how I do it in Excel. So we are in Excel. So go to the formulas, go to the more function, go to the statistical function, and try to locate norm.s.dist. Norm.s.dist. This is the function, right? He's asking what is the z value. Z value is 1.71, and he's asking, are you looking for the cumulative area from the left? Yes, we are looking all the cumulative area from the left. So the answer comes out to be this one. Let's round it to the 4 decimal places. The reason is that we have the table. Our table consists of 4 decimal places. That would take the answer for the 4 decimal places. So 0.9564 is the answer. So we have the same answer as we have in the table. Let's see another example. Find the p-value given the following information. It's a right tail test with z equal to 0.75 as a test statistic. So let's see. We have to draw a bell-shaped curve. This is the bell-shaped curve. Exactly in the middle, I take the mean value 0. It's a 1, a 2, a 3, a minus 1, a minus 2, and a minus 3. Right? Let's plot this value 0.75. So 0.75 will be somewhere here. This is this value. This is the value of the test statistic, and it's a right tail test. Look at that, it's a right tail test. So when we have a right tail test, the p-value is always the area to the right of the test statistic. This area will be the p-value. This is very important that you understand. This area will be, so this was my test statistic, 0.75, and I have to find the area to the right of it. But remember that when I look at the table or I use Microsoft Excel, the Excel will always give me the area to the left of it. So I have to use a smart thinking in order to find the area to the right of it. I hope you understand this technique from the chapter number 6. So what I'm going to do now, I'm going to use Microsoft Excel and I'm going to find this area. Let's go to the Excel. So I'm already in Excel. So what I do, I insert the formula here. So before I enter this one, I have to do a smart trick, this equal sign, 1 minus. Now I enter the formula. Formulas, more function, statistical function, and I have norm.s.dist. norm.s.dist. This is the function, and now we enter the value. Z value was 0.75, and he's asking, are you looking for cumulative area? I say yes, I'm looking at cumulative area. True. And when I plug in OK, so the answer comes out to be 0.2266. 0.2266. So that's the p-value. So that's the p-value, the probability value. So this value comes out to be 0.2266. That is the area on the right side. I hope you understand that. Let's see another example. Find the p-value given the following information. This time you have a two-tailed test with z equal to minus 0.17 as a test statistic. So in the previous example we had a left-tailed test, then we have a right-tailed test, but now we have a two-tailed test. So when we have a two-tailed test, you have to be a little careful about the calculating the p-value. We have to double something, keep in mind. So let me show you what I'm trying to say. First you draw a normal curve. Let's draw a normal curve like this. Exactly in the middle it's a mean value 0, and we have a standard deviation 1, 2 and a 3. We have a -1, we have a -2, and we have a -3, right? Now what we are going to do now, we are going to look at this value minus 0.17. Minus 0.17 will be somewhere here, right? This is somewhere here. So this is the this is the value of our test statistic. Let me write here minus 0.17. Now our test statistics is on the left side of this center value, right? It's on the left side, and I told you when the value of the test statistic is on the left side, then what we do, we find the area to the left of the test statistic, but we double that area. Why we double that area? Because it's a two-tailed test. So what I'm going to do, I'm going to find this area, and the p-value in this situation will be equal to 2 times this area. 2 times this area. That you need to understand. In case of a two-tailed test, we always multiply the area 2 times. If the value of the test statistic is on the left of the center, then you find this area, the area on the left of the test statistic, and you double it. So what I'm going to do, I'm going to find this area by using Microsoft Excel, and I'm going to double that. Let's see. So I'm already in Excel. So what I'm going to do first, I'm going to double the area first, and now I'm going to compute the area. First I double that, formulas, more function, statistical function, and norm.s.dist. Norm.s.dist. Let's find that. Norm.s.dist. This one. He's asking what is the z value. Z value was minus 0.75. I think minus 0.75. Minus 0.17. Sorry for that. Minus 0.17. So this was minus 0.17. And he's asking, are you looking for the cumulative area? I say yes, I'm looking for the cumulative area. Right? So what you do, now you multiply this one. You already multiplied this, you already twice it, and you hit OK, and here's the area, 0.8650. So the answer comes out to be 0.8650. So let's write the answer. So this area comes out to be, this p-value comes out to be 0.8650. I hope I copied correctly. Yes, 0.8650. So I told you how to find the area in both the cases. Now we already found the p-value in 3 different cases, in case of a right-tailed test, in case of a left-tailed test, in case of a two-tailed test. Now the question comes to the mind, how we are going to use this particular p-value, how we are going to decide our test. So I'm going to tell you what is the decision criteria. Right? Remember, we always compare this p-value, with alpha. And what is alpha? Alpha is the significance level, and it is the complement of the confidence level, right? Alpha usually 0.05 or a 5%. So we always compare p-value with alpha. And what is the criteria? If the p-value is less than alpha, we always reject the null hypothesis. And if the p-value is greater than alpha, let me repeat once again, if p-value is less than or equal to alpha, then we reject the null hypothesis. And if the p-value is greater than alpha, we say we have failed to reject the null hypothesis, right? And an easier way to remember is this: if the p-value is low, mean less than, h naught has to go, means you have to reject it. If the p-value is high, mean greater than alpha, then h naught must fly. It means we are not going to reject the null hypothesis. This is a way of remembering it. This is not my discovery. I found it from the internet. I like it, and I'm putting it here. I don't take any credit for that, right? So what we're going to do now, we're going to do some example to understand that. Let's see some examples. So we have an example here. The p-value for a hypothesis test is p equal to 0.034. Somehow we found this value. Do you reject or fail to reject the null hypothesis when the level of significance alpha is 0.01? So I told you that whenever you have the p-value and you have the significance level and you want to decide what is the result of the test, you compare these two values. You compare p. Now clearly you can see the p-value is greater than alpha. You can see that. You can compare 1 on 1, 0, 0, 0, 0. This is 3 and this is 1, right? So this number is larger than this number. So in this situation, we see p-value is greater than alpha. And what I told you if the p-value, so in this situation, p-value is greater than alpha, it implies that we reject h sub 0. In this situation, we reject the null hypothesis. So if the p-value is greater than alpha, we always reject the null hypothesis. I hope you understand that. Let's see another example. Now let's see another example. The p-value for the hypothesis test is given as p equal to 0.006. Do you reject or fail to reject the null hypothesis when the level of significance alpha equals to 0.01? I told you, whenever you are given a p-value and you are given a level of significance and you want to decide what is going to be the result of the hypothesis test, whether we are going to reject the null hypothesis or we are in a position to fail to reject the null hypothesis, you compare these two values. You compare a p-value with alpha. Clearly, when you compare number by number, some people have a difficulty in comparing 0, 0, 0, 0, 0, and 1. So this number is a smaller number. So in this situation, the p-value is less than alpha. So what happened? What I can say, p-value is less than alpha. And I told you when the p-value is less than alpha, we always reject the null hypothesis. So what we say we reject h sub 0. So when the p-value is low, h naught has to go. This is exactly what I'm doing. P-value is less than the significance level, so that's why we're rejecting the null hypothesis. So what we have done now, we have seen the basic vocabulary of the hypothesis testing. Now we are in a position to outline what are the steps involved in the hypothesis tests and how to perform, how to tackle a problem, how to solve a real problem by using hypothesis test. And this is exactly what we are going to do in the next video. I hope you understand this video. Thanks for watching.